Creating a science storyline at CCSD. This screencast will go through the process of creating and implementing a science unit using the storyline format. A quick review. The science storyline will be created around all science standards within a topical arrangement. The standards will drive the selection of a phenomena, the creation of the driving question, and the opportunity to collect students' questions, which will help drive the lesson level phenomena. Teachers will also predetermine the science and engineering practices, what students will be doing, the disciplinary core idea, the content, and the cross-cutting concept, how the students will link it all together. Lastly, the teachers will determine what the students will take away from each lesson that will help them with answering the driving question about the anchor phenomena. So we have our storyline template, and then remember up in the corner we linked in all our lesson plans. Okay, so you're starting your physical science unit on motion and matter.
Yes.
So I did print off too for us the different standards with the evidence statements. And let's see, so we have 4 standards that fall in 3rd grade for physical science. These are the 4 standards under the topical arrangement of forces and interactions in 3rd grade. All 4 will be used to design this unit storyline. Before starting the storyline, understanding the standards is essential. So that's kind of our standards, but can you just tell me a little bit about what's in the kit?
Okay.
I'll put some notes down.
Okay, so I do know that one of the things is I think it's like investigation 1. There's a lot about magnets and them, like interacting with them, and talks about force, balance and unbalanced forces. They don't always know, like the poles are different.
Does it get into, okay, so we have force, balance, unbalanced. Does it do like attract and repel?
Yes, those are 2 of the words they learn.
The first unit is kind of about magnets. Is the whole thing about magnets?
No, and then we get into like wheels, but motion, like wheel and axles, the way they turn, motion, more like we make like the twirly birds where like the air, making them go down. So this one's more of the wheel, the axle, the ramp, like the motion going down.
So, and stability.
Yeah. And it goes to applying this. And they had to try and pick up magnets, so it kind of comes together that way, I guess.
Okay, and so in the end it ties
So it's kind of like a
together.
STEM, then they test it, and then they get to redo it again. So I really feel like that's like a great STEM. You know what I mean? Because they're designing, they're using their knowledge to design.
Okay, so, yeah, and we can even use that throughout. We don't always have to wait to the end, but we'll see how it plays out. Then part 4 is
mixtures.
So, this has kind of 3 distinct pieces. Magnets, force and motion of objects, and then the mixtures piece. To unpack the standard, you can use the NGSS site. You can access your standards by topical arrangement by going to nextgenscience.org. You then click on the advanced search link, which will give you the standard by topic option. From there, you can access your grade by level.
I'm going to be starting a new unit in science, and it's called Motion and Matter. So I want to show you this poster and what I'm going to be referring to it. There are 3 really big parts of being a scientist, and scientists do all these things. Some of the things I'm going to talk about, or we're going to talk about, are things that also happen in math. Patterns. In reading, we talk about cause and effect. And so lots of these things that we talk about kind of happen in other places too. But as a scientist, you kind of think about it in a little different way. So today, we are going to be practicing asking questions. Really, it's asking questions and defining problems. We're going to be working on asking questions. That's our main goal today. One of the main things we're going to talk about during this part of this unit is cause and effect. And remember in reading, when we talked about cause and effect, something happens, so something else happens.
After we break down and understand our standards, we must create an anchor phenomena. An anchor phenomena is a compelling natural phenomena in science, or a meaningful design phenomena in engineering. Using phenomena-driven instruction motivates students to be the scientists they naturally are. A good anchor phenomena builds upon everyday student experiences. The anchor phenomena requires students to develop and apply multiple performance expectations, which are our state standards. When designing an anchor phenomena, we need to make sure it is too complex for students to explain in just one lesson. Students will need instruction to be able to explain, and searching online will not be able to yield a quick answer. The anchor phenomena should focus on knowledge, not content, because content can be Googled. A good anchor phenomena has relevant data, images, and text to engage students in the range of ideas needed to understand. Using a broad sequence of science and engineering practices to learn science through first-hand or second-hand investigations is key. Anchor phenomena will take students a whole unit or a large part of a unit to explain the science behind it. The example that will be shown will be the anchor phenomena magnetic slime for half of the third grade kit Motion and Matter. It will engage students around Investigation 1, Forces, and Investigation 4, Mixtures.
So we can, when you're thinking about phenomena, we can do it two ways. We can do multiple phenomena if we can't figure out how to mesh it all together for like the first half and the second half, and then try to pull together, or we can try to think of something that will tie all the pieces together.
Okay, I'll have a couple ideas, like thoughts. So fidget spinners are big right now, but then if we did fidget spinners, it would just be motion going. It wouldn't be magnetic. It wouldn't be mixtures.
Can add magnets though to fidget spinners because they are metal. So there are, I've seen different ones where you can set them on the top or on the bottom and see if you can change the direction that they're turning. So like you spin it, and then if you put a magnet on, if it'll change direction and stuff. But it depends on what kind of fidget spinner.
Right.
So that we could tie in the magnets and the force and motion, but that wouldn't let us
do with mixtures.
But we can always do two different ones. Through YouTube, there was a video that was called Magnetic Slime, which I linked there. So that would make, we could talk about if it's a mixture or solution.
Okay.
It's magnetic. And then we can cause it to move, so then we can get the forces and motion. So.
Wow.
And then I think it would be one of those things is we can show the video, but then if we create it after every single investigation, they can manipulate the slime to see if they can get it to attract or repel or
so cool.
Move forward or backward.
Yeah, I'm kind of loving that.
The way this kit was designed, finding an anchor phenomena to encompass forces with a focus on magnets, patterns of motion, mixtures, along with how to be an engineer was challenging. That is why two anchor phenomenons were created. Magnetic slime was used as a way to hook students and get them curious about magnetic forces, along with what is a mixture. A student going super slow down a slide was used to hook students on patterns of motion and engineering a solution to this problem.
So I want you to put your scientist cap on right now. And I want you to watch this video thinking of yourself as a scientist. Remember, scientists wonder. They're curious. They think. They ask questions. So we're going to watch this video.
It's like that's a tree.
I'm going to let you watch it again. And I want you to be thinking, if you look at your paper, it says, what I noticed.
This is mine.
And then you're just going to say, what I wonder. So for every notice, you can ask a question about that. You notice something, then you wonder something about that. Does anybody have a question or a notice and a question they want to share? We'll just take like a couple, okay? Miss Olivia.
And how does it?
It climbed, so yours is kind of similar. It climbed the magnet, and your question is, how does it climb? How did it climb the magnet?
Whenever they put a metal object close to the slime will attract it.
All right, so he noticed right away. Whenever a metal object was close to the slime, that it was attracted to it. And so what's your question?
That was my question.
Oh, how?
I noticed. What I wondered. What was the slime? What was in the slime to make it attract the metal?
What's in the slime to make it attract or go toward the metal?
The driving question is a way to initiate and focus inquiry around your anchor phenomena. The question may seem simple on the surface, and yet is very complex. Since the driving question is tied to the anchor phenomena, the driving question cannot be answered with a yes or no response and cannot be easily answered through a Google search. The driving question will be answered through multiple disciplinary course standards, which would be tied to multiple performance expectations, which again are our state standards. To answer the driving question, it is essential that students must participate in different science and engineering practices and use a variety of cross-cutting concepts throughout the unit. As teachers design driving questions based on their anchor phenomena, they must be thinking about these two important questions. What do I want students to understand? And how will they show their understanding? As you will see in the planning video, the driving question created around the anchor phenomena of magnetic slime was, what is the mystery material and what causes it to behave the way it does?
What's our question going to be? So
Well, I think,
say, do we have a question like, okay, watch this, and then what do I say? Like, what's the...
it's fine that they know that it's magnetic, but our question wants to kind of be, by the video, why does it behave the way it does?
Oh, okay.
Because see, here, and sometimes it's taking the magnet and sucking it in, but sometimes it's pushing away from the magnet, and then sometimes it's coming toward the magnet. So, kind of, what is this mystery material? And even if they figure out it's magnetic, that's fine. But why does it behave, or how can we make it behave the way we want it?
Because then they had to explain that.
So, like when we learn about repel, can we get it to push away from us?
Oh,
when we learn about attract, can we get it to attract?
Right.
Down for now, friends. I'm going to show you a question that we're going to come back to. It's called our driving question. It means the question that we're always going to come back to for this unit. And the question is, what is the mystery material and what causes it to behave that way? Lots of you kind of go, oh, I know what that material is, and that's okay if you think you know what the mystery material is. I heard the word slime, I heard the word material, I heard the word stuff. And you're one, but our question is, what is it and what is causing it to behave that way? Why is it acting that way? We're not going to answer that right now, but I want you to go back to your I notice and I wonder, and add any questions thinking of it like this. Do you have any questions, any wonders to add? You're just writing down. If you have any more wonders, you're going to write them down. I mean, you've got 2 minutes to think. Are there any more I wonders now that I know what my question is?
As you noticed in the video, the I notice and I wonder strategy helps students pull out the questions that they have. The strategy can be used to collect questions from students after the introduction of the phenomena, after the introduction of the driving question, and during and after lessons. Creating questions can be a hard task for students in the beginning, reminding them for every observation they make, they should be able to create a question about what they observed. Also, if they start their question with I wonder if, they are setting the stage for what they come up with to be indeed a question. This strategy is used to get students to observe and question. We need students to question so they are invested in the learning. It gives learning a purpose. Student questions can be used as lesson-level questions tied to lesson-level phenomena that drive the learning, and students use evidence collected from day-to-day science experience, videos, readings, graphs, charts, and so on to build understanding around how to answer the questions the class have created. Again, student-created questions give purpose to the learning.
Okay, friends, I'm going to stop. You're not going to tell me any of your questions because you are going to write each question down on a separate piece of note card. Okay? So if Maddox has 2 questions, how many do you have, Maddox? Right? 2? Okay, so he's going to write his first question on this one and his next question on this one. When you have your questions written, please bring them over, just you and your questions, bring them over to the right place.
And if you always start your question with, I wonder if, then it always is a question and not a statement.
What we're going to do, I'm going to ask one person to read their question, and then we're going to see if anybody else has a question that's kind of the same or similar. So be listening to the question to see, oh yeah, that's kind of like mine. And if you're not sure, we'll help you decide if it's similar or not. Okay?
I wonder how does it climb? Like,
How does it climb?
I have the same one.
You use the same one as her? Okay, I'll take it.
So those are kind of more about the material,
Yes. Okay, just wait.
the mystery material.
Yeah, so this one's more about the mystery material, but I'm going to put it over here. Is it you have one like this one, David?
Yeah. No, not.
Okay. You have one like it?
Yes.
What's yours say?
I wonder how it knows when the magnet is there.
I wonder how it knows when the magnet is there. How the material knows? Is that what your question is, Nadia? Like how the material knows the magnet's there? Okay. And how it climbs? Perfect. Those are kind of the same. Nat?
I wonder what the person put in the slime to make it magnetic.
Wonder what they put in the slime to make magnetic.
It says, I wonder why is that slime connected to each another.
I wonder why it's like connecting to each other. So that's kind of, so I wonder why the slime connected with each other. So that's kind of about the slime and moving and climbing. Okay. We're going to Maddox, you have one? Oh, wait, I'm sorry. Does anybody have something similar to that? Okay? Similar to that idea. Now.
I wonder if the slime can stick to anything else.
Can it stick to anything else?
I got one. I have something similar. I wonder why it covered the whole object.
Why did it cover the whole object? When you look over here, one of the things they do is ask questions with what you're
Providing students the opportunity to question, whether at the beginning of the unit or throughout the lessons, allows students to go through the natural process of inquiry. Students are able to question about why, when, what, and how things happen. Again, students' questions should be incorporated into the unit storyline. They can be used at the lesson level as a phenomena question or the focus question. They can be embedded within the science lesson to help drive or focus the learning, or they could be used as a way to extend students' learning. Students' questions and question boards become a way to promote curiosity, capture learning, and show progression around a concept or concepts. By allowing students to make connections to different science and engineering practices, disciplinary core ideas, and cross-cutting concepts. There are different ways to create and house question boards. Teachers can use a physical question board where students write their questions on sticky notes or index cards and they hang them on a wall. As students collect evidence, they can physically match the evidence to the question it helps answer. Digital question boards, such as Padlet and Lino, give you a platform to collect questions, respond to questions, along with linked pictures, resources, and evidence in a way that does not take up your physical space. Both are equal in value. It is up to personal preference on which method works best for you, your class, and your space. After students ask questions, the questions must be organized. As a class, students and teachers collaborate around how questions can be categorized. Teachers then use the question categories to create a logical order for exploration. The order is created in a way where insight and learning experiences build toward understanding of the anchor phenomena. This happens at the lesson level through the classroom experiences using student and teacher-created questions to drive instruction, which will make lessons and investigations more intentionally planned.
Video, you have your board. So their questions go on the index cards. These are my I wonders. And then we're going to categorize them like we have like in science council or whatever. Like, these are all go together, these all go together, these all go together. And then do I write like one question, like when we did that colorblind thing. You know what I mean? Like, or whatever. It was like, all these questions are about the brain. All these are about colorblindness. All these are about blah, blah, blah. So then do I write one general question or just keep them all questions?
You can put categories, because when we did that, we just put brain and then we put them all in one. But however you want to do them. If you can think of a question that you want that all those questions fall under, you could categorize it.
Okay, I have to wait and see kind of like what the questions are. Like if there's enough together. You know what I mean? Like,
right, and they might not categorize it necessarily how you would categorize it, but as long as it's a somewhat of a category and they can identify with it.
So you suggest they do it, right? It's their categorization, not mine.
I mean, you can help drive.
Right.
But yeah.
The lesson level phenomena is written as a phenomena-driven question. These are smaller lesson level phenomena that help the students figure out the pieces of the larger picture or anchor phenomena. The lesson level phenomena are the puzzle pieces, and once we get all the pieces, we can solve the puzzle and answer the anchor phenomena. We want students to be engaged day in and day out, and our anchor and lesson phenomena do this. They help motivate students to actively figure out rather than passively learn about core ideas in science. Investigation by investigation, we want the science to do the convincing, not us. Students can reason their way through lesson level phenomena without having all of the vocabulary. Vocabulary can come after students warrant the need for the vocabulary word. They have understanding and an experience to hang the vocabulary word on. A couple lesson level questions for this unit were: what happens when magnets interact with other magnets and or object? And how is the magnetic field affected when more magnets are added?
So it looks like we have our phenomena as magnetic slime. We have our driving question, what is the mystery material? What causes it to behave this way? So then, got investigation 1, you said was all about magnets.
Yeah,
right?
and gravity.
So the focus question of investigation is what happens when magnets interact with other magnets and with paper clips. We can make it a little bit more generic so that it's not tied to just this investigation, because keep in mind we're using slime.
Right.
And there's other things that are magnetic.
Or about what happens to magnets when they interact with other magnets and materials? Or what would you say?
What happens when magnets interact with other magnets and with paper clips? Yeah, I think we could do what happens when magnets interact with magnets or other materials.
Mm-hmm.
Just keeping it more generic so that it's not just tied to paper clips. We're going to use paper clips, but then we can have them, they have to apply it outside of that. So if you look in this investigation, it looks like they are going to explore the forces of magnetism. Pretty much this investigation, if we're thinking about our storyline, the first part is kind of like what depth of knowledge. They're really just making observations, and we're just collecting data on what, or evidence on what magnets do. Push, pull, force, attract, repel, magnet,
gravity,
and gravity. And they have that as the first thing you do is give them the vocab words, and I would wait.
Okay.
If they don't have an experience to tie it to, the words really have no meaning.
Right.
So I feel like if you do these investigations and then we tie the vocab words back to it, then they've all have the same experience.
Right.
To make meaning of the
I'm going to write these vocab.
And then the major science and engineering practices, we're going to be asking questions because that's that first lesson, and we're manipulating and observing. Cross-cutting concept. So if we're really working on push, pull, attract, repel.
Cause and effect. What causes it? Or what effect? Right. What causes the attraction? Yeah, that makes sense.
And we kind of want, when they're explaining it, to put those words in for them. So when they say, I put the magnet here and it did this, then we can replace that with the cause of the magnet being moved here was this and the effect was this. So replace
start using those words.
Yeah, and then kind of talking about it, and then they'll start to gradually replace them.
Can you tell me what your results were from your experiment?
Yeah, so we caused the paper clips to quiver by the magnet by hanging them over the magnet. The effect was the paper clips pulling toward the magnet.
Could you tell me what your results were from doing the talking magnet experiment?
We caused the magnets to shake by putting them close together. The effect was that the two magnets were repelling and pushing away.
Thank you.
Then we give them the slime and see, can you make it push, pull, attract?
I think it would be better at the beginning just because there's so much. You know what I mean? Like there's so much.
The next day.
Right. So I think like there's so, like, remember what we learned yesterday, like now we're going to do the slime to see what you can do.